Okay, I am back for more of Odinmade Hero, and as usual, I need to make sure that I have not been bamboozled by YouTube or Twitch. Looks like we're good. Today is day 50, and that marks 5 weeks of me learning from Casey here how to make a game one day at a time. In the Odin programming language, just kind of porting his C and C++ work over into Odin to enlighten myself as to how to go about programming a game. And it's been a lot of fun so far. I'm definitely enjoying myself. I feel like I'm internalizing the information that he is trying to get across a little bit better this time around, and I think it's a combination of just more exposure to the subject matter, and also Odin just kind of gets out of my way as a language a lot of the time, and I'm just thinking about the thing it is that I'm doing and not so much how to do it. But again, that could be just more and more exposure to the domain and thinking about, in particular in this case, how to move an entity through a game world in 2D and kind of 3D space. So we're just picking things up as we go, and the information is becoming more and more well retained. But yesterday we had some issues with this movement code where we're trying to handle collision detection with these walls that we have in our little tile map room. And Casey ran into a bug, which I called ahead of time. I actually was able to spot it this time as opposed to when I was working through the series in Zig, and I could see that the old player position was not correct coming back around after the first time through, because that recanonicalize call was being called after updating the entity position. So things were just out of whack coming around the next time. And I think that confused matters a little bit because Casey was trying to figure out how to handle the wrapping, because the game world is like continuous. It never begins or ends. I mean, there's a beginning. There's like the first tile index that we start off on. One tile in and one tile up in the X and Y, but you can wrap all the way around and come back around to that first tile index in the very first slot there. So that bug was kind of confusing matters, and he was trying to work through this loop. And I was also just confusing myself because, one thing that I'll point out, and I don't want to spend too much time on this because I do have a limited amount of time, and it looks like Casey's going to do a bunch of blackboarding to introduce us to Minkowski-based collision detection. And so we're going to have some blackboarding there and then jump into probably a bunch of code to start implementing that. Before we do, I wanted to point out something that really bugged me once I realized. I was, once again, thinking a bit too hard, and I was wondering, how can I do these 4 in-range loops in Odin, so that I don't have to do this C-style for loop syntax. And I was looking at it like right after I ended the stream yesterday, and I was like, you know what? It's literally this simple right here. And I don't know why this didn't occur to me sooner, but I was looking at this for like 3 streams in a row, and I was like, how do I do this? It's literally just, this is the stopping condition, is once we get to equals 1 past, whatever that max tile is that we set. And this is saying, keep doing these things, keep adding 1 to the abs tile Y or X for as long as this isn't true. So I don't know why my brain did that, but it's not the first time and it won't be the last. Point is, all I had to do was change it to this, and this is actually the same as this. But I've also got these new names because I decided I like the start tile Y and end tile Y naming better. So now I can just kind of smoke that, and we can think about some of the other stuff that was going on. I was trying to really make sure I understood the problem with the wrapping, and Casey actually went into detail a little bit with this during the Q&A for the previous day, and he explained that, essentially the problem we have is that And let's say that if we start out on, you know, old player P being, I'll just pseudocode this. Old player P starts out at 1, 1. You know, this is the X and this is the Y. And then we travel down, right? Because that's the case that I've been looking at more than anything else, because that's wrapping, right, all the way to the end of the world, essentially. Right? So if we do that, now we're still on the first X tile, but we go down to something like, you know, the max U32 value at the very end of the world in the Y direction. Now, the problem is that when we take the min of these two values in the Y, so that would be here and here. When we take the min and the max of these values, we get the min as being the old player position, and then we get the max as the new player position. But we've actually wrapped around when we've done that. So it's this weird case where actually we want to go from here, we want to iterate from here to here. And this actually kind of does that because we add 1 to the end. So maybe this just, you know, max U32 plus 1 wraps it back around to 1, if I'm not mistaken, and I very well could be. Because, you know, U32s can only store such a high number in them before adding to them wraps them back around to 1, right? And, you know, there could be something going on here where actually that is not behaving the way that I think it would in Odin, you know, because maybe this is actually, maybe this only happens this way in C or C++, or maybe even this is the wrong way to think about this, but this is the way that I'm thinking about this. And so I think it's basically the problem that Casey illustrated, that if, you know, if we start out at the min of here, a min of 1, and then we're going all the way to the end of U32, like let's say, for instance, we didn't actually add plus 1 to the end of this, because I think if we didn't, we would run into this bug where we're basically just stuck in this iteration, because we're going the entire length, which is like 4 billion tile indices, right? So that is the crux of the issue, I think. And he was thinking about how to handle that for doing this collision detection, and how this was going to have ramifications for also, you know, how we deal with the camera, because the camera is fixed per room, you know, in the which is affixed to the screen dimensions. And so there's just a bunch of other consequences of doing things this way, which is why he ultimately decides to walk that back. But I'm thinking about just how I would want to handle this. And I actually, so what I did was I renamed, you know, this stuff to be this, so that I can just interchange these variables with what his current implementation is, because I couldn't get this implementation to work, where he just kind of affixes the start tiles to the old position and the end tiles to the new position. And I actually went back to this, and it just sort of works. And it even works when wrapping, which I can't make sense of, because I would have thought I would have run into that bug, which I think he showed, where he's basically just getting stuck in a permanent loop. And it isn't perfect because we're actually getting stuck inside of walls, which is kind of weird. I wasn't seeing that behavior, and then all of a sudden I was, but I think that could be because of how I'm getting these values out. I really can't be sure about that, but decreasing, or actually increasing, this epsilon value kind of alleviated that. So if I just bump that up real quick and then rerun it, I don't get stuck in these walls. At least not that I've been able to tell. Or maybe I still can, but it's a lot harder. So now I get stuck on them. Like the collision detection doesn't have me smoothly gliding against them or anything, but at least I don't get stuck inside of them, unable to get out. So there's that. But if I go back to, what is it, that code to remove the, that's not what I wanted to do. I wanted to look at the code where we're setting these wall tile values. So we'll say we don't want there to be any south wall again. And then I rebuild this. The other part of what was confusing this, as I just mentioned, is that there's camera considerations to keep in mind. So if I go off of this, you know, I was getting stuck in the world because there was no value, no tile chunk existed, and then I would get stuck in the wall because I'm basically colliding with a wall because there's no tile chunk beyond the bounds of the world. So I was just kind of getting stuck in the end of the world essentially because it hadn't been created yet. Because that collision code, you know, the epsilon being too small, was allowing me to get wedged in there, and then there's no way out no matter what I do. So there's the camera kind of messing this up. So I, you know, was looking at this and I thought, and I think Casey might have actually tried a case like this where we just temporarily enable the smooth scrolling by overriding these manipulations we're trying to do with the camera relative to the player's position, because that's a whole other thing where the whole wrapping of the game world creates issues for the camera because it doesn't line up perfectly with the screen dimensions, right? Whatever that really high 4 billion number is, it doesn't quite line up. So if I just say that the game state camera position is actually just whatever the camera following entity's position is, our game player, our hero, now we'll kind of smooth scroll wherever he drops in, and I can actually go off the world and it seems to wrap just fine. And we can actually prove this by printing those values out. But in my head, I feel like this shouldn't be working. And in fact, there is something strange about it because, and look, you can see right there, I just got stuck. So my understanding is still not great. There's still some aspects of this that are odd to me, but I guess I can go ahead and print that out to actually show that that wrapping is happening. So now when we build, not sure why that's taking so long, and then run the game. So we'll print out these tile values, and then if I come down here, it's jumping around right now. Oh, because we're stuck. Now we're stuck in between. I'm still getting stuck. See, it's really weird. But you can see right here, it's kind of hard to follow, but the abs tile Y has wrapped. We're down in the, you know, the high, or I guess the low 4 billions here. And we're on those, and now I'm stuck again. But you can see right here, we've wrapped, and then at some point we kind of just get stuck, and I don't really understand why we're getting stuck, but the game isn't freezing basically, because it should be ranging from the old player position basically when we transition, once we do the wrap. And of course it's going to be too many values. I'll just kind of, there we go. So we're on the 0th Y index, and then we wrap down all the way back around, and we're on the 4 billionth, et cetera, 95th Y tile in the Y direction. And then I'm able to drop down into the 4 too. So once I get down into, you know, 93, that I get stuck on a wall, which is strange. I just don't, but basically this is the problem, right? Is going from 0 to 4 billion and whatever should be taking forever and then kind of freezing out the game. And actually, if I use the old implementation here, where we're just going straight off of the old and new player positions, instead of doing this min and max stuff, that will actually create that bug, I'm pretty sure. See, and now essentially you can see that the output is stopped, and that's because it's iterating from 0 to 4 billion or whatever as we wrap. So I guess I understand the problem well enough to know why it's bad enough that we need to rip out the world map wrapping. And it doesn't really seem to have much benefit, which Casey also talks long enough about to where I'm fine with moving on from this point, because it's already been too much time spend thinking about it, because there's much bigger and more important fish to fry. And the point is now that I am basically back up to parity with where he was at. What was that? Room, something about a room, bottom, door, bottom. There we go. So we'll back that out, and camera. Actually, let's just check out. Get all these changes out of here, and then go back into our move player code. Max, yeah, right here. Get rid of this. And so now we're kind of starting off. I'm handling these loops differently now, in a way that works just fine. I collide with all the walls of the room, which is what we want. And we're going to change it a bunch anyways. And I'm not getting stuck so much if I don't worry about the wrapping problem. But it still happens from time to time. It's just much more rare if you're not dealing with those really large tile values. Like, I can't even produce it now. So anyway, that's enough of that. That's where we're at. We're in a good place to start off today and try out implementing this new collision detection. So here we go.
All right. Hello, everyone, and welcome to Handmade Hero, the show where we code an entire game from scratch, live on Twitch, no libraries, no engines, so we can see absolutely everything that has to go on to make a game actually work. And there's a fantastic amount of stuff in there that has to go on to make a game work, and it can be really fascinating to kind of get in there and see all the stuff that happens, I think, anyway. It's really interesting to me, and I hope it's interesting to you as well. We are on day 50 right now, and we are just about to finish up the sort of collision detection stuff that we were doing. Basically, what we're in the middle of right now is a pass over the code at the beginning, where we're basically specking out everything that we want in our engine. So we're doing basically crappy versions of all of the things that we think we will need to make the game run properly, so that we have some functional skeleton in place that we can look at and go, okay, we see how everything works together, we see what the requirements basically are for each thing. Now when we go do industrial strength versions of each of these pieces of code, first of all, we have the other pieces of code in place working, if albeit jankily, which is kind of important, so we can see how things work together as we make new components. But also, it's so that when we go off and make a new component, and we're trying to do like a good high-quality version of it, we're not doing that in a vacuum, because when you do stuff like that in a vacuum, you tend to make a lot of mistakes in terms of how it will interface with other things, and you forget certain requirements that maybe you wouldn't have thought of if you hadn't have looked at the usage code first. So always write the usage code first, big mantra of mine, and that is exactly what we're doing. We've gotten to the point where we have a collision detector that basically actually already works. It works better than I thought it was going to work. I thought this version was going to be jankier than it was, but it's not at the moment. But that's okay, because we still have a feature to add to it anyway, so I'm going to do a little bit more on the collision detector before we put it to bed and say, okay, everything else that's going to happen with collision detection is going to happen when we do the final version of it. But there is one more thing that I want to do, because I think it's relatively important to have something like it in place, and that is basically area-based collision detection. So we'll talk about that in a second. For now, if you are one of the fine fellows who has pre-ordered Handmade Hero from handmadehero.org, you will note that today we are on day 50, which means that if you download the source code that comes with the game from last night's post, day 49 source code is in there, unzip day 49 zip into a directory, and you'll be right where I am today. So if you want to follow along, that is the day to use. Okay, let's get started here. Let's take a look at where we were. So we did some debugging yesterday. Our collision detector is now, unfortunately, more solid than I would have wanted it to be. So we basically have two things to do today. One is that we have to actually do gliding now, like we want to be able to glide along edges instead of stop. And the other is I would like to have area-based collision detection. You'll notice that it's just point-based collision detection right now. It's that point at the base of his feet, so he can kind of go into objects slightly, which we don't want either. So we're basically just going to fix those two things today. That's our primary goal. The first one is probably a little harder than the second one in terms conceptually, because I already talked about the math behind the skating, so you kind of already know what we're going to do there. And so right now, all we really need to talk about is how we're going to do that sort of that area-based stuff. And so I guess what I'll do is I'll start off with that, because in case that takes the whole time, we can always do skating on Monday. And the skating is, like I said, we already talked about the math, so it's not going to be as big of an investment. So let's talk about what's going on.
Thank you. No. Get over here. Thank you.
Love you.
Love you. My gorgeous wife has brought me tea again, which is always much appreciated. All right. Sorry, Casey, carry on.
On here, over on the whiteboard, or as we might call it, the tan board. So I guess it kind of looks like a chalkboard now. So what we were doing, right, the way we implement our collision detector is we wanted to start doing collision detection where we knew when we would hit a wall, instead of just taking a point that we were at and a point that we were trying to go to over one time step, right? This is one time step, one frame, and saying, is this inside something or not, right? And when we did that, that was problematic because it meant that we couldn't do skating like we would want to do, and there's a bunch of other problems that we were going to have, that like tunneling. There were problems with doing it this way. So what we decided to do was switch to a method where we actually solve for the time at which we would hit something. So we solve for that intersection point. So now we know between the 2 points, we actually check if any collision could have happened along there, right? But in order to do that, we made a simplifying assumption, which is we simplify it down to checking a line versus whatever the shape is that we were collision detecting against. In this case, we were collision detecting against 4 walls of a tile. And in that simplification down to a line, obviously that means that the person, that little fellow in there, he doesn't have any area at all. He's just a point, right? He's a point moving along a line. That's all we're testing. So what we need to do is now talk about how to make him a little bigger. And I'm going to use the simplification that we're just going to make him rectangular, because that's going to make it easier for us to implement, because we're not doing the final collision detector now. But what I'm going to talk about is actually going to be the same. The actual theory behind it is the same no matter what shape he is. And so I'm going to talk about him as if he was a circle as well, and stuff like that, just so that you understand that conceptually the way that we're thinking about this actually doesn't matter. But implementation-wise, you have to step up to slightly stronger algorithms if you want to use dissimilar shapes. And I'll explain why in a second. So
to really drive that point home forward, did that sentence come out intelligible at all? To really drive that point home, I watched, it was like within the most recent 100 days of the Handmade Hero series. It's like in the 600s. And the last episode he did was like 669 or something. He was doing sphere-based collision detection, which sounds a lot harder than what it is that we're going to try and do today.
What we're doing here is we're going to talk about something called the Minkowski sum, also the Minkowski difference. And what's interesting about this is that, like, Minkowski algebra, there's like, Minkowski was probably a pretty cool dude. I don't really know anything about him, but I suspect that he actually has a lot to say about a lot of things. And unfortunately, I am one of those people who only learned enough about what he did to do collision detection. So really, it's one of those things that's like on the bucket list. I would love to go read all and actually really understand all of his algebra stuff and how he worked with shapes and everything, because I suspect that there's probably some really cool stuff that I could do if I understood it, and I don't. I never learned enough of it to really know. So I'm going to tell you what is basically the game version of Minkowski sum and difference, which is the stuff we need to know about the work he did. Oh, I'm losing my voice. This is going to be a gravelly one. Which is the stuff we need to know about what he did to basically do what we need to do for collision detection. Okay. So essentially what you could think about is, imagine I had 2 walls with a gap between them, okay? And these walls each have, let's say, if we took their center, I guess it's hard to call it necessarily a radius because it's not a circle, but imagine there's like a radius which basically says, you know, the dimension here, right? They have a dimension of something, and we'll call that, I don't know, S for now, okay? So basically these walls have a dimension of S. So they are 2S this way and 2S this way. They're squares, let's say, okay? And then I've got my guy, right? And I've got my guy here. And he, let's say, has a radius of r. So he's 2r this way, 2r that way. And when I do my collision detection, what I want to do is I want to drive him through here, right? And we can see just intuitively that he's too large to fit. So there's no way that you're going to fit this. This opening is less than 2r, right? So there's no way he should be able to fit through here. But obviously, if we were doing collision detection the way I talked about doing it in the simpler form when I was teaching how to do that basic line intersection, well, if he shrinks down to a point, he'd fit through there no problem. We can easily pass rays through there. There's tons of rays that would pass straight on through there and not have a problem. So the question is, what can we do that would make it so that we could still do collision detection continuously along a ray like that, along a line, so that we actually get analytic and we know we don't tunnel through anything? What would we do to do that so that we could still solve it with a guy who had an actual size to him and not just a point? And so the interesting answer from Minkowski is that you can actually do a form of algebra on shapes. So in much the same way that you might imagine having something like a plus b equals c, right? An equation like you would learn in high school algebra, or even earlier, you could imagine saying, oh, well, if I want to talk just about A, I can move the B to the other side and say it's A equals C minus B, right? And these are 2 ways of writing the same thing. That's really handy, right? Because this allows us, even just those basic operations allow us to do a lot of things. We've already used that a ton of times in all the code that we've written just so far in the game, and we'll use it a ton more. Algebra is just really handy, those simple operations of being able to move things to either side and talk about what a particular variable equals. If you have some kind of hairy equation over here, it's pretty cool, right? And it's very powerful. Well, we can actually do stuff like that with shapes as well. What we can do, if we essentially think of this as being a point, right, that has this radius here, and that radius is what gives it its volume. Instead of thinking this as having to cast, right, like what we would do if we wanted to do this intersection, instead of thinking of it as having to sweep, essentially, this whole square through here and actually do testing to see whether we overlap with these pieces, what we can do instead is say, let's pretend that we did shrink this guy down to a point, what would we have to do to these shapes to make it so that a point moving through them behaves the same way as a rectangle would move through the unmodified shapes? And the answer is actually very simple. It's just we would have to grow these shapes by this shape. So essentially what you can imagine is taking the perimeter of this shape and sweeping this rectangle around it, right? So you imagine sweeping this rectangle all around it, and we would end up with a shape that was like this, right? And you imagine me doing that here as well, sweeping that, taking this rectangle and sweeping it all around the outside and taking that outer boundary, right? And now we produce two new shapes, right? That actually, if you can see, you can actually see intuitively what it is. It's S plus R. They're rectangles that are S plus R from their center out instead of just S. We now have two shapes that if we raycast it against them would give us the right result. You can no longer pass through there. And you can see that actually as R gets smaller, if R was like that small, they would have still left a gap that we could still pass through, which is correct. So as R crosses the threshold of how big R would have to be to fit through here, it creates a gap or doesn't create a gap based on that. So what the Minkowski, that's called the Minkowski sum there. Excuse me. I believe technically this term is sort of not even a real term. I think it's usually just considered a sum, and you're either doing the sum with a negative or not. I don't know. It's a little odd, but Minkowski sum is the name for that. So where does that leave us, right? What does that actually do for us functionally? Well, if you think about, oh, Krita, here it comes. Look at that. Oh, but it didn't. Why didn't it use my background? What, guys? What's going on with that? It's supposed to clear. It's supposed to clear to my background color, right?
It never fails. The evolution of figuring out how to have a good drawing software that just does the thing that you want it to do.
You saw it happen, didn't you? You saw that happen. Why did I get chumped? All right, hold on a second. Can I fill this with something? Can I do anything? Phil. What's going on here? Phil. What? Okay, seriously? This is just absurd. You guys saw that happen, right? And now I can't seem to undo. Why can't I undo? This program is fired. I don't even know what it's doing at this point. I feel like it shouldn't be that hard to just have a thing that draws. Okay, there we go. Well, that was disappointing. That was supposed to be the big moment, and the big moment was totally flaccid, is basically what happened. So how do we clear this thing? There's got to be some way to select stuff, right? How do I select just a region in this program? Does that select a region? That looks like it drew a rectangle. There, that selects a region. So if I select this region, right, I feel like I should be able to clear it. Can I not clear it? Clear. I don't know. How about fill with foreground color? I can't fill with foreground. All right, guys.
This is the start of a new series where you spend 600 days learning how to use Krita, the drawing software, from scratch. Where did my mouse just keeps jumping across?
Guys, seriously, this is just ridiculous. Unacceptable behavior on the point of the drawing program. Unacceptable is my opinion. How come I can't really do anything anymore, as far as I can tell? Like, I can't even do the old way that I used to clear stuff. All right, if that's the way you want it. I guess we got to make a new drawing. New drawing. And we're back. Of course, I can't apparently get the colors that I wanted either. This is just a disaster. This is the worst thing ever. I just want, at this point, I think I have to write my own drawing program for this stream, which is absurd. Like, okay, where'd that layer go? Does anyone see it? I don't see it.
I've actually been wanting to try one out so that I can get to a point where maybe I'll want to start drawing things out, not for educational purposes, but just to help organize my thoughts. But of course, then I think I have to get like a tablet and a stylus and all that, and it's going to take me months, if not years, to research what I want to buy to be able to get, because there's going to be the tool that's perfect for me, and I don't want to buy the less optimal thing because I'm out of my mind. But the creator of Odin just released a new drawing software that I guess is inspired by an older one, but it's written in Odin or whatever, right? So I need to take a look at that. Maybe that'll be, and he's charging like nothing for it, but maybe that'll be the thing that I look into whenever I get to that point where it becomes more about like sketching out potential game design ideas, just getting my thoughts out. And I'm finding more and more that I've never been a note taker. It's a hard thing to do. It's a hard thing to get disciplined about, I guess I should say, because it's just another thing that I have to do. And I'd rather spend as much time doing the actual thing I want to do instead of writing my thoughts down. But if I don't write things down, then my brain gets all fragmented and I'm just forgetting really important things that I need to do, like, whatever it is. I miss a bill or something like that, and I can't be having that.
Where's my layer? I think we've got some kind of weirdness going on with the other ones. We have like a vector layer that it created. I don't want a vector layer, to say the very least. I want that gone. All right. So that's probably what happened here. We got some weird vector layer in the mix, and then we couldn't clear it. It was clearing that other layer. Lame. All right. Well, at least we got something working. Man, what an interruption. So annoying. Okay, anyway, back to the topic at hand. Now that we've got that straightened out, we'll clear this guy. Okay, so what I wanted to talk about before I was so rudely interrupted by Krita is that if you think about what happens here, right? If I have any shape at all, and I want to do this Minkowski operation, so I want to shrink this shape down to a point, and I want to expand this shape by it so that I can do raycasting on it as if it were just a single point coming against it. Again, I sweep the shape around the perimeter of the shape, and I get the result. So if you imagine putting a circle, right, and sweeping it around the perimeter, right, you can see that basically this plus this, right, equals this shape. It's a rounded rectangle, right? There's my new shape, right? So that's how you do the Minkowski sum, or how you can conceptualize the Minkowski sum. Now, that's a very complicated thing to think about because you're like, well, okay, great. Conceptually, that makes sense because I'm a human and I can just imagine sweeping a shape around another shape, no big deal. What does the computer actually do, though? Like, how do I code something that works that way, right? And the answer is, well, in one case, it's pretty simple, right? In the case where you have two shapes that are essentially the same shape, right, like two rectangles, and you want to do the Minkowski sum, all you're talking about is taking the dimensions of them and adding them, right? If this one was r and this one was s, like in the previous example, then if I want to shrink r down to a point, I just have s plus r as my new rectangle, right? And that's done. So if they're two shapes that are exactly the same, it's actually pretty easy. You just expand the radius and you're done, right? But there's kind of a hidden assumption there as well, which is that those shapes also have to have, you know, some way to easily parameterize them like that. But like for rectangles and circles, that would work, right? If we did circles, the same would be true. If you had a circle of radius s and a circle of radius r, and you added them together, you get a circle of radius s plus r, right? So that's really easy if you have that. But if you don't have that, it gets a little more complicated. Like what about this rectangle case here where I've got a rectangle plus a circle? You can see that it makes a much more complicated shape. And so if we were going to do, say, raycasting against that, we would have to do very specialized raycasting to raycast against circles and rectangles together to make this sort of composite shape that produces the right answer no matter what you were raycasting at, right? And that's actually, it's not terribly hard to do even that, but you could imagine much more difficult ones that were like super crazy, like, you know, oh, this is my shape and I'm adding it to like this shape or something, right? And that's going to be this crazy thing with this swept around there that's got like another convexity here and whatever, right? So you can see that it would get pretty complicated. So there actually is a way that we can do operations like raycasting and those sorts of things against very complicated Minkowski sums if we want to, which is called GJK, actually. Which is named after the people who this is one initial from each of the people who originally invented the algorithm. There is a general purpose algorithm called GJK that actually allows you to do essentially any Minkowski sum operation that you want to do in that way for things like raycasting or collision detection with any shape at all, as long as it's convex. So you can't quite do something like this without first breaking it into convex pieces, right? Which would be something like this. And that's actually pretty common in collision detection, to take concavities and break them into convex pieces, because operations on convex pieces are so much faster that it typically is better to just do 4 operations or 5 operations instead of 1 operation and do them on convex. So typically what ends up happening is
there's a Microsoft engineer who talks about how the Doom guys basically broke down their map geometry in a similar way until they no longer had any, what was it, convex pieces. And I can't remember the exact, like, if there's a name for the algorithm. Basically, it was something that Carmack had unearthed and applied, you know, from mathematics or something, I believe. And it may actually be related to, if not exactly what he's referring to here. But basically, that Microsoft engineer wrote a book about this and all these other things that made Doom kind of this, like, lightning in a bottle type situation where the right people came together at the right time and did all the right things to just revolutionize gaming, right? And nothing was ever the same.
This will becomes like sort of a workhorse that you use for the collision detection, and you just end up doing it so that you break all your stuff into convex pieces first. Now for our game,
I should really plug him. I think, let me see if I can remember his name. Yeah, I'm pretty sure. Yep, and this is the book. He had like an online version. I need to buy the paperback version. I haven't bought it yet just because I don't have time to read. Looks like the PDF is working again. Nice. I made it like 25% of the way through his book, and then and then the PDF, online PDF, stopped working. But it looks like it's up again. And so, yeah, pretty interesting stuff. It's not just like a super technical book. It's kind of like a history book as far as all that goes. And I'm going to go and work on finishing reading it in my spare time.
I don't know that we'll ever actually have all that many concave things. I suspect we'll have mostly convex things anyway, so this part might not be a problem. But we may need to implement this as our final collision detection system, because we may want to do some crazinesses like polygonal convex objects, for example, and circles and all that stuff. And at that point, it becomes pretty difficult usually to conceptualize how you're going to do stuff with a raycast, so you typically want to do something that's GJK or GJK-like to do it. But for purposes of just what we need to do right now, we probably don't have to implicate... okay, thank you. Ah. Krita. Oh, Krita. At least it's free. At least I didn't pay for it. I guess that's one thing to think of. You get what you pay for, and it turns out that's not very much. Okay, so basically, like, what we're doing right now, if we just want to do rectangles, like I said before, we already know how to raycast against a rectangle, right? So if we have point versus rectangle, we actually already know how to do that, right? And so if we want to, we can easily make the guy be a rectangle as well, and we can say, you know, okay, if we want to make this guy into a rectangle, no problem. We'll just take however big the guy's radius is and add it to the radius of the thing we're testing against, and we're done, right? That's it. So we almost don't have to change our code at all, thanks to Minkowski. Just to do a simple area version, it's pretty trivial, thanks to him, right? Thanks to Minkowski. And so you can imagine how we'd implement this in code. It would actually be really easy if we want to give that guy some radius. Right now, right, he comes up here, and he can, you know, go through things really easily, and he interpenetrates through. And if we wanted to say, let's stop doing that, let's give him some more girth there, what we can do is just in the code, why do I have another one of these as well? I have no idea what's going on with Rita right now.
Let's go girth.
Okay. If I want to go into the code, which it looks like I didn't ever even open up my editor yet, so let's open up the editor. Let's see here. There we go. So if we imagine what we would do to our code here where we're testing all the walls, really we already sort of determined what the shape of the wall was by using min corner and max corner, and what we did is we took the tile sided meters and we divided it by 2 to figure out what the span was. So all we would have to do is just to min corner and max corner, instead of using this as the radius, like this is effectively our radius for collision, right? It's the tile map tile sided meters. Instead of just using that everywhere, which is what we were doing before, all we have to do is grow that radius now by however big we wanted the player to be, and the player suddenly would have that much area as a rectangle, right? So I don't remember what we set the player width and height to, right? We have some kind of a thing like that, I believe, that we set earlier. Not that it actually meant anything, but we actually did have one, right? So somewhere in here, we've got, there we go. So we've got an entity has a width and a height, right? So when we are doing that collision detection, when we're doing that, we have a entity, we have a width and a height for the entity. So what we could do when we do that radius value is we could say, okay, we've got a radius, we've got a width radius, and we've got a height radius, essentially, right? And for the tile map, it's the same in both cases, but in the case, and this is actually, I guess this is more of a diameter here, because we're dividing it in half in a second. So this is really the diameter, right? So I've got diameter, width, and diameter, height, like so. So I can think about just going, okay, for the width, I'm just going to add that entity width in there, and for the height, I'm going to add that entity height in there, and that's the width and height that we said that the person was, right? And so I don't actually remember exactly what we were doing with that, but it's kind of, I think we were using that more for drawing, but I'm just going to use that for collision detection at the moment. And so now I believe that rectangle is the size of the collision area, or should be. Oh dear, what did I do there? That didn't work at all. Okay, I've made a slight error. I apologize. My bad. I don't actually know what I did there. So I said that it should work. Apparently I was...
Well, apparently what he wrote in here is wrong, but I need to get caught up in here anyway. So take the diameter, and I don't know, maybe I should just, yeah, we'll just make these two individual. Well, you could just make it, yeah, this seems pretty straightforward. You could do something like this, plus the entity's width. Yeah. Tile map, tile side meters, plus entity's height. And then, I think I could just do this. Right? And no, it's not going to do the thing that we want it to do. So we'll have to change something about it, but... Oh no. I got stuck. got to be because of the way I'm calculating those start and end tiles that I just get stuck the second. Whoa. The second I hit anything that I should collide with. No, that was just like a freak accident. Super lucky. There we go. Now I'm stuck. All right.
I was quite mistaken. Hold on a second. Let me see what I did wrong. So we have the tile map side in meters. We're adding that entity width and height. Let me step in there and make sure that and let me see what's going on here. So we've got the min corner X and the min corner Y, which is correct, right? Yeah, let me go ahead and recompile that and make sure. And let's step in there and see what I did wrong there. I believe that should have just worked, but it is fairly early in the morning, so I may just be... Let me go...
He actually has these in reverse, and that makes more sense to me anyways. Test the min first and then the max. It really doesn't matter, but I just don't want to get confused later on because I see things out of order. Yeah, that all looks right. We throw T-min at the end because that's going to be a pointer instead of a plain value. Seems like we're okay.
Go ahead and recompile that and make sure. And let's step in there and see what I did wrong there. I believe that should have just worked, but it is fairly early in the morning, so I may just be delusional, and there's a step that I'm forgetting here. So let's find out. Okay. So let's... There we go. So when we get into a tile that we're supposed to be colliding against, oh, right, never mind. I know exactly what the problem is here. So we do have another problem, which is that when we actually look at all of the tiles, and we figure out what the minimum and maximum tile are that we're going to loop through, we do have the issue of looping through those tiles. We have to take into account the size of the entity, because we may need to grab more tiles than we would have grabbed that we could be colliding against. Yeah, this is kind of obvious. I'm not sure why I didn't mention it before. Just wasn't thinking this morning. So if you imagine, what we were doing is we were doing a little iteration over basically the entirety of the tiles that were touched. We were looking at something where we were saying, okay, let's say the guy moves from here to here. And we said, okay, what are all the tiles we need to check? Well, we just need to check the tiles into which that falls, right? But that's not actually true. Because if you think about it, once the guy has some area here, he actually could hit walls that are in tiles that are further away than that. So what we really need to do is look at this corner and this corner, right, of that, and say, what are all the tiles that those would overlap? And that is actually all the tiles that we need to check. So the reason we can tunnel right through stuff now is we're actually looking at things that we've already passed by them by the time we check them. We've already gone onto the inside of them. So yeah, so that's a fairly obvious thing. I don't know why I didn't think of that before we hit it. And so yes, there is another step, and that is the step. So I'm going to go back to doing this the old way because we didn't really need what I was doing before. And I want to also do some kind of assert here. Let's see. So I can actually move this loop back to the way that it was as well. We can actually do something like this, where we do min tile and max tile, right? Because we said that we're not going to allow wrapping anymore because that was just going to be too much of a pain to maintain. At least I believe it will be. So we're going to do something like this, where we just are back to the good old, familiar, easy way of doing things. So we basically have our min tile y, our max tile y, and we loop over them. Max tile x is less than...
All right, I might as well do things like that then. If that's the way it's going to be, it's a pretty easy change. I just didn't like the one past stuff. We don't need that. And now we really don't need it. But there's other things here that I see where it's like, man, I just don't want to spend all this time typing out new player. And it is just going to be probably generic at some point where it'll just be, entity or just new P. That's probably what I would do going forward, but kind of neither here nor there. And I think the rest of that looks good.
Equal to, because this is always just easier to think about, and so I'm kind of glad that we don't have to deal with the wrapping anymore, because that was just going to be a huge pain. Okay, so there we go. And we need to make sure that we never actually wrap as well. So we probably want to do some kind of assertion. Something like so that we know that when we've wrapped min tile x something like the fact that these should always be less than some reasonable value, right? We shouldn't ever be getting the gigantic 4 billion ones here. So I'm just going to slap one in there so we know, because we haven't actually moved our world to the center yet. That's something that we would like to do. And so just in case we forget and do some stuff off the edge of the screen there, I wanted to warn us so we know what happened and we're not like, what's going on? All right. So assuming that I do that, I just want to make sure we're still good here. Okay, there we go. Assuming I do that, I would now like to go ahead and account for basically that player size, this thing right here. So what I want to do is I want to make a min player p. That's basically what I really want to do is I want to extend these by however big the entity is in tiles, right? So after I do min tile x, max tile x, so on, I want to take like the min tile x and I want to subtract it by the entity tile width, right? Basically, I want to do that, and I want to do the same for the min tile y, right? I want to expand that rectangle out like I drew in the diagram. So I want to just go ahead and do that. So what I need to know is I need to know how big the entity is in tiles, right? Round it up, basically. So what I want to do is say, essentially take the ceiling of that. Let me take a look and see. I don't actually remember if we ever did ceiling. Did we do ceiling or did we only do floor? Let's see, floor. So we did floor, but we never did ceiling. So I would like ceiling for this operation, right? Seal F. There we go. Again, that should be something that we can get to be relatively in line eventually. So what I want to do here is say, okay, well, the entity tile width, I know his width in actual, in like meters, right? I know his width in meters, but I want to know what his width would be in tiles at this point, right? So I want to know, and there's two ways I could do this, right? I could do a slightly more conservative bound by putting it actually into the computation here and then rounding out the tiles, but I'm not going to bother with that. I'd rather just do a slightly more conservative thing for now, and we'll let that be something to worry about in the final collision detector. So what I want to do is say, well, whatever his width is, divided by the tile side in meters. And I guess, to be honest, I don't really need, now I think about it, I don't really need the ceiling, so maybe I shouldn't bother putting that in there. I don't know, we'll leave it in there, just in case. But all I really need to do is say, okay, if I have the entity width and I have the tile side in meters, then I can divide the width. Yeah, sloppy drinker. I can divide the width by the tile side in meters, and that will give me how many tiles he would expand by, right? And so I can take the ceiling of that, and I'm expecting that to generally be 1. But, if you had like a real big entity, you can imagine it spanning multiple tiles, and then it might be a wider expansion. So I figured I'd just do it the way that we would, that we would want to do it. So we're just going to take a look at that and say, okay, let's go ahead and get that out there. And since this is an actual integer function, so what we should do now is if we step in here, we should see that box expand by that min tile x and min tile y when we go to do collision detection. So
he called it to int 32, so I see that and I go, hey, my brain is breaking. And that's going to take in a float, and I'm just going to cast that to a U32 cowboy style, because obviously there's going to be something wrong with this assumption that that's going to create the right value that we want as a U32. But so be it.
let's take a look at what we...
The right answer is probably to like add one and truncate. And I guess I didn't even see what he implemented that function as. He just uses seal F, so never mind. He's just using that math.h call, it looks like. So maybe we'll just roll with it.
By that min tile x and min tile y when we go to do collision detection. So let's take a look at what we computed. Yeah, 1 and 1, which is exactly what I thought it would be. And then when we've got our min tiles and max tiles, they look like they're coming out correctly. So now we're going to expand those, min tile x, min tile y, max tile x, max tile y. So we're going to expand those out so the mins get smaller, the maxes get bigger, which is what we want. And now we're doing it over a wider radius, right? And so I believe that should solve our problem. And it does. Of course, we do have one more thing to solve, which I'll talk about in a second. So I think we're basically, this looks like it's actually working exactly.
I'm stuck again. I wonder if I've just done something terrible and not implemented that test wall proc the way that he did, because I'm getting stuck all the time. Look at that. Why do I keep getting stuck? Maybe my epsilon is too small. Whoa, that's definitely not right, right? That looks more right. I'm not getting stuck either. That's wrong. So what on earth happened?
Right. We should also probably stop drawing the walls this way because the walls are actually bigger because remember I took 0.9 of them away so we could see around them. So it looks roughly correct. All right, so ooh, very sticky there, which of course is again because we haven't actually dealt with what happens when you actually hit the wall yet.
Oh, thank goodness.
So one thing that's happening now, though.
So he has the sticking bug, which is good. I'm no longer worried about that test wall proc being slightly off since we're going to update that anyways here in a moment. But we are not colliding with the east and north walls, which is bad. So it makes me think that I did something wrong down here. Diameter width is, well, yeah. It's vector 2 of floats. And then the min corner is this, the max corner is this. I don't see why that's a problem. What have I done? Is it this seal call? Wow. Way to start off stuck. That's just great. I don't understand why. How could this happen? Getting stuck everywhere. We have our assertions, we have our T-min. None of this stuff really looks wrong to me. So why are we not colliding with those walls? I'd at least like to get stuck on them. I wonder if multiplying... Yeah, no, I feel like this should just work. But maybe to cut down on the possibility of it not working. And then this would be like that. I mean, this is just the same darn thing that it was before. So, don't expect it to work, but if it does, I guess that would lead to me questioning my sanity. Yeah, so there's something else going on. You know what? I probably didn't change this loop, or did I? I did. His is inclusive, or it's sorry, it's less than or equal to. Huh. As long as it's less than or equal to. Yeah, okay. Dang, man. How hard is it to write a correct for loop, you nincompoop? So I'm gonna walk this back. Since that worked fine before. And we should be good. Jeez. Some lessons are learned the hard way, and sometimes they're learned the hard way like dozens of times before you stop being silly about it. Yeah, I am an ignoramus, it's true.
That you can notice is when we collide against this side and when we collide against the other side. That's very sticky. I wonder why that's so sticky. That's weird, right? Don't you think? Not that is sort of what's interesting about that. I wonder if we have another bug, but this is what I was expecting to have happen to our collision detector before, and I wonder if it's just because all of our stuff was tiled aligned that we weren't having that happen. It's just kind of like this is the stickiness was what I was expecting to happen with the old collision detection, and that I was going to talk about how we would have to get rid of it and so on. But anyway, so I feel like something bizarre is happening there too, though, because I believe we're still using an epsilon when we set things away. So I think we've just got a straight up bug in there as well. Because if you remember, we're actually placing the guy a little bit away from the wall. So when he tries to go the other direction, he should not actually still be hitting it. So I do think that he shouldn't actually be getting stuck in that fashion, even at this early stage with the collision. So I think we have another bug in there that I'm not thinking of, but I'm not sure exactly what it is. So we'll have to think about that in a second. So anyway, point being, what I was going to talk about first is the fact that you'll notice we're drawing his height off of this pixel here. We're drawing his height offset from where he actually is. Right? So his center point, where we're drawing this rectangle, we're drawing him as if the whole height comes off of that bottom point, right? And so what happens is, when I hit the bottom edge, I stop where I would have stopped if the rectangle was done this way. And of course, that's exactly what we would expect to happen because the collision detector is treating it as if it's a radius value out from that center point. So what we actually want to do is talk about just this area, or whatever the area is that his collision is going to be in. We want that to sort of be the center of where he collides against, right? And we don't want to start to think about it in the other way. So the entity width and height is actually going to be about that, around wherever the center is of his collision, and what we want the bounce to be around there. So I want to start drawing him that way because that's the way it's actually going to work. If I go take a look at where we're doing that drawing for the entities, you can kind of see what I mean by that. We basically have a thing where we do the player left top, and you can see that we subtract the whole height. So what we actually want to do is subtract half the height. So now it's centered just like the old one. And you can kind of see that is more the rectangle that we're talking about, and that one stops the way that you would expect it to stop, and so on. And so now we're actually correct, but that is not the size we would probably want to use for that entity width. So what we probably want to do is make his entity, his entity height. So we probably want to do is make his entity height a little bit better. So I believe that's an initialized player. And so this is not really the height, it's really his collision height. And I don't know if we want to talk about his actual height as well. So we may want to actually talk about dimensions in a slightly different way. So I'm not sure how we want to talk about this eventually. So for right now, we'll say that it's just going to be something like, 0.5 and 0.5. I don't know, how big is that? Let's find out. That's a little bit, oh. That's not what I meant to do. That's what I meant to do. There we go. Yeah, so that's a little too small. Let's make it still a little bit wider. So maybe his width is about 1 and his height is about 0.5 because of just the way the game's perspective is. That's probably a little bit more like what you would expect the shadow of the player to be. And so off he goes through here and so on. And he can hit things like we would expect. Okay, so what I'd like to do now is before we go ahead and do the gliding, our area collision is working properly. But before I go ahead and do the gliding, I want to figure out why we're getting that sticking problem, which is bogus. Okay, there we go. Yep, so we've got our area collision back. And as you can see, with Minkowski makes a lot of things much easier than they would otherwise be, because you can basically use the same code that you would have used for something else, and you just fiddle with the inputs a little, and all of a sudden you get something great, right? That's what you wanted. So you can also see, though, and this is why I say that eventually we want to do circles, you can see how with the rectangle, I kind of would stop here, and there'd be really no gliding I could do, whereas with a circle, it would kind of roll me off into inside, once we actually implement the gliding code, which we haven't done yet, right? But you can see that that won't actually improve. So yeah. So what I want to do is I want to take a look at the sticking now. So what I want to do is know what's happening here, why I can't get out of here. I want to actually just look at the code directly and find out why we're getting the sticking, because I feel like with the epsilon, we shouldn't have been able to do that. That's obviously not true. And so, yeah, so I'm going to go ahead and set our loop point here. So I'm going to do a loop point set. I'm going to move out for a while so that I know that I'm trying to push outwards and then loop it. All right, so I'm going to go in here and say, let's go ahead and step in and see what's going on. So we're here. Let's go ahead and step in here. So we're basically only checking two tiles. We're checking the tile that we're on, and we're checking the tile below us. Basically is what's happening there, right? If you look at the min tile x and the max tile y and max tile x, let's take a look at the DDP, make sure it's something that we want. So that's not actually a DDP that I want. I wanted a DDP that was going to be actually trying to move us down, right? Why is my DDP always so tiny? Obviously, the collision detector can't move us anywhere if the DDP is always super tiny. What is the meaning of that, people? What is the meaning of it? Why is that happening? I don't understand. I recorded a thing where he was definitely moving down. We should be able to get a DDP where he's actually moving himself down, but it doesn't seem like that's ever happening. Let's go out and see why not. Okay, game update. Let's see. So, no one... What? What is the problem here? I do not understand what's going on. There we go. Okay, so I guess it just stopped in the middle of one randomly. All right, so the controller's not analog, ended down, so ddp.y is -1, ddp.x is 1. We move in here, see what we've got. ddp is 1, -1. So we have to renormalize. We get the right thing. Multiply by the player speed, which is good. What? His velocity was negative that? Did you see what I saw there? How did his velocity be equal to negative what it was? What is going on here? We're not even updating the velocity, right? Oh, is it just... Oh, are we just seeing literally that fact that the velocity is never getting updated because we haven't actually gone and done any work to correct it? That seems odd, though. Why would that be the case? I guess I could imagine that being the case. Let's just see if that's true. I'm going to go ahead and test that just to make sense, because that's pretty interesting. I guess if we just gone and implemented gliding, we would have gotten rid of the problem. But yeah, so in this case, when we did the tmin there, when we sort of looped through here and found it, basically we're saying is if tmin is less than 1.0, then we would want to go ahead and zero that velocity out, and that would just stop him entirely in his tracks, right? Is that really the problem? That seems odd, but I guess it could be. Let's find out. It does look like that was indeed the problem. Well, totally fine. That's fair. All right, so I guess that means we really didn't need to debug that, because if we'd just gone ahead and finished the gliding implementation, where we were going to update the velocity for our new collision detector, it would have just worked. But hey, it was good to inspect anyway, so that we know what it was and aren't, worried about it, I guess. So that's fine. So we're now in good shape. We've got the area working fine. So all we want to do now is implement the gliding. And to implement the gliding, we just have to do the same thing that we did before, right? Where we update, basically using that same idea here, where we did.
No shit. So I thought, yeah. Well, I'm glad that, it turns out if you copy exactly what he's doing, you have the same bugs as him. Isn't that strange? I thought I had some other bug, though, because I didn't see him sticking in the last stream at all. And then all of a sudden, he's sticking all the time in this one. So there you go. Just goes to show. So now I'm wondering if I, backed off the wrap asserts. I might wait until after the stream to test this, because I'm just curious for myself. Like, will I get stuck at the edge of the world, or will the wrapping work just fine? I don't understand why it was working with that old implementation, but maybe it was just because we were, like, right on the line. I don't know why I'm so curious about something that it basically has no consequence, but it's just for the sake of the knowledge. I want to learn. I want to learn the thing.
Our sort of our bounce equation, right? Where we actually take away all of the bounce velocity and just leave the remaining velocity, right? So if we want to do that, we still have the exact same code essentially, but I'm going to make it a little bit cleaner. So basically, if we go down here, I'm going to say that after we do this test wall bit, I'm going to go ahead and say that we got to update our velocity instead of doing it this way. And what we're going to do is we're going to do this inner product thing. You notice that the way that this is set up, it's saying that the existing velocity.
I did not see where he grabbed that. Where did that go? Where is my dot? This right here. Why is this even broken up on 2 lines? I think that's a reasonably lengthy line, reasonably wide.
We subtracted away the part that we didn't want anymore of that velocity, right? And by doing the way that we did that is we used an inner product with essentially the normal, if you remember, the normal to the wall that we hit. And what's nice about this equation is this actually works whether or not you hit a wall, because if we just set the normal of the wall to be 0, 0, this term would evaluate to 0, right? So what we could do is just say we always update the velocity with whatever wall he hit, and then we just have a wall normal, right here, that we're going to track. So we have wall normal, and it's going to be equal to 0, 0 always, right? And then we're just going to update that along with our tmin. Actually, trying to think of how I want to do this.
While he thinks about that and takes a swig, I'll go ahead and add in that wall normal. And then he was debating whether to update that inside of here, but what I need to do is change out these R variables for wall normal. And what do you know? Looks like we're gonna split it up again. I don't know. I guess that's like just wide enough. My problem is I don't want it going off of the end of my editor, but I've been thinking about adding in wrapping or adding it back in. I don't know. I tried adding wrapping in, hoping that it would line up the language server errors before, but actually that's not what I want to do. I want to go into my app data and then go into what? Oh no, wait, it's local, and then my config is in here. Yeah, I'll just change it since I'm thinking about it. Let's go down here. Thanks for letting me know about that trailing space. So we'll go blah blah blah. Can't talk. If I go back down here, dp equals this stuff down here. So now if I like did a trailing operator, okay, that expects an operand. What if I do that? Yeah, see, it doesn't wrap the error message. I wonder if that's a setting that I can actually change. I guess if I just tab it over, it'll scoot the error message over, and maybe that's what I'll have to do in situations like that where I want to read an error, but I don't want to like build and then scroll. Like, just show me the error in my editor and don't make me work to see it. But maybe I can have it like, maybe there's a setting that says just always add errors on a new line. When I first saw something like that inside of, I think it was VS Code, it made me irrationally angry because I was like, don't get this out of my face. I'm looking at my code. If it errors, let me just suck and be free from your barking messages. Anyway, that's enough of that.
Because I don't think this thing really knows what the wall normal is. So let's do it this way for now. Right, wall normal equals whatever the normal would be. And so we're basically just doing the exact same code that we did before, only this time I'm setting an arbitrary wall normal. So we could expand this code, I guess, to use walls that were not, like nothing in the code now really counts on the fact that the walls are horizontal or vertical, except our sort of not particularly good solution up here to testing the wall. It's this code right here would have to get a little bit better to handle a slanted wall, but that's about it.
So he's gonna have to turn that into proc that returns a bool. Never a big fan of having these really long procedure. Well, I guess we can change these at some point to be, yeah, no, you wouldn't want to change those to be vectors because it's always a different thing anyways. You just have to plug them right in. Really long procedure signatures bother me, and I think it's like a clean code ism that got embedded in my psyche that I've never been able to quite get rid of, because it is not a big deal. It's just I should pay more attention to the procedure name and less all of the crap that you have to throw into it to get the result that you want. So I'm actually not sure what this would be. Do I even need to specify the type? I don't, because we've already declared it. Isn't that so nice of Odin to do that for us? Test wall doesn't return anything. We'll say that it'll return a bool, and we're going to say that the result is a bool. Return that result, and I'm guessing it'll just be something like that. And then over here, let's see if I can deduce this without Casey hand feeding it to me. So if we test the min corner x, the minimum corner on the x plane, then we'd actually be, the wall normal would be going up in the y direction. Is that right? And then it would be the opposite. It's weird because we're testing the Y value. Yeah. If it's the Y corner, but I think it's because Y goes like this, right? Y goes down, not across. I don't even know how to express what I'm saying here, but I think actually this should be reversed, maybe. I don't know. We'll see. They say it's like usually your gut instinct that is right, so maybe I'm going to bamboozle myself. And actually I had it right the first time, but we'll see. Yeah, if it's min, if it's max, negative, okay. Let's see.
So what I want to do is say, all right, we can return whether we hit.
Do we need parentheses around entity delta p minus 1? I don't know. Around here? Well, we actually don't even need this 1. Actually. Because so this goes all the way back to the reflecting of vectors. If we had this as a 2, it would reflect this vector right here. In fact, I think I can show that, assuming this will even work the way I think it's gonna work. Yeah. Wow, did I get it right? I got it right. He just kind of bounces because he's being, you know, accelerated in the other direction as he bounces off. So he just kind of knocks his head. He swivels his head back and forth. See, now we're bouncing. But we don't want to bounce, right? That's what that goes back to. So the 1 is there for like posterity, but it actually doesn't even need to be there. So I guess I can just get rid of it. I think he might have still kept it around. But now you can see, yeah, this is what we want. We're still not gliding quite right because, I mean, we are gliding right in that we're back to this where I can actually move along the walls and not be stuck. But if I try to like press into them in a way that would like, if you think about running into a wall where it would kind of decelerate you a little bit as you're running into the wall because you're creating friction, right, against the wall. We don't have any of that. It just kind of stops us dead in our tracks. Okay, I thought you were trying to subtract. Yeah, we're subtracting the 1 times the length of that vector to basically stop our momentum going into the wall so we don't get stuck on the wall as we're trying to move around it. If we did a parentheses around this, that would be like, you'd just be subtracting 1 from each of the velocity members, right? So X would be slightly slower, and this would just get you stuck more, I think. Maybe you'd just get stuck in the wall if you did this. Yeah, so now I'm like trapped. I'm moving. But because my velocity is always being... In fact, I can't even change like the direction that he's facing in. What's that about? It's all kinds of messed up. But anyway, you get it. We'll just get rid of that because that is a little bit confusing because there's no point in multiplying all of this by 1. Right? Just, it's unnecessary code. There we go.
Or not. So hit equals false, and in this case, hit equals true, right? So we'll return true, return hit. And now I'll just go ahead and set them.
I think I already did all of this, right? Because we jumped ahead of Casey, but he called it hit. I'm just going to leave it as result. I like result as like a boilerplate. This is what I'm dealing with here. This is what I want to return. And it's initialized to false by default. And we're good.
The normal to what I know each of these wall normals to be, and off we go. So in this case, I'm testing against the min corner x, so that normal would be in that direction. For the max corner x, it would be in the opposite direction x. Same thing here.
I mean, it looks like mine works. So either he's got them swapped, or I have a bug and I don't realize it.
And here, right? And so I believe that should update our velocity correctly now. Excuse me. So we should be able to glide if I didn't mess it up, which I may have. And it looks like I did. Did I forget to, what did I forget to do here? So wall normal, I feel like, why is he stopping there? What did I mistakenly do?
I love it when I'm right. Not to get egotistical about it, but I had the wall normals correct, and he messed them up at first, but I'm sure it was just because, you know, as I have already done myself multiple times, and as he points out all the time, there's something about splitting your attention between programming and, like, talking through what it is you're doing that actually makes you a worse programmer. Although I think after enough years of doing it, you probably get better at it. And it's honestly this for the same reason that like doing Let's Plays on YouTube back in the day made me seem like a shitty gamer. Like unless I was really focused and concentrating, if I was just BSing and talking while I'm playing the game, I'm going to miss things and people are yelling in the comment section. I'm going to be worse at, you know, boss fights and things like this, and I'm just going to suck. I'm a worse gamer, but I'm like trying to think through what it is I'm saying as I'm playing the game and as I'm saying it, and it just, you know, you can't be perfect at either task. So then you're tripping over your words and you're also so you just look bad in the end. And like the skill there is to like get as good as you can, you stay as good as you can at both of those things while doing them at the same time. I think some of that comes with practice. But that's like one thing that like a backseat, you know, gamer, right, watching somebody stream a game or play a game or whatever, doesn't appreciate when they start criticizing somebody who's playing a game on stream. Like, oh, you missed that. Oh, you did this wrong. Like, look, they're trying their best. They're not trying to be, you know, they're not trying to suck at the thing they're doing. It's like Mythbusters testing driving while on the phone. Do they crash a lot in Mythbusters? I never watched much Mythbusters. But it was sad to hear that one of the guys passed away, right? He was pretty young, too. That's what I remember. That's like the last Mythbuster news I heard was that one of the main guys on the show had passed away.
There's one thing we need to do in addition to this, but I feel like I should have glided properly just from that. Yeah. Let me verify that it's not the other thing that we need to do first, and I'm pretty sure it's not. Oh, okay, so it actually is. All right, never mind. I take it back. Okay, so now we're at the situation. He actually is gliding properly. I take it back. You can actually see him gliding properly there. The problem is we have to do the final thing that I said. If you remember when we talked about... I thought he was going to complete stop. He actually isn't. He's only stopping if we continue trying to go to the wall. So we're at the point where we can finally fix the final problem that we had.
Huh, maybe I am wrong. Maybe I am wrong. Because, I mean, I thought that what he was saying there is that he expects to be able to glide, like, against... while you're not trying to hold down. Glide against the wall, that is. Which I can, so maybe I'll just try this. I'll just swap these around. I at least got the plane right, if nothing. And then I'll see what the difference is. There's actually no difference. What? That does the same thing. How can that be? Huh. Oh. Well. That, I didn't yank and paste correctly. So this would be, I think this was negative. And then this was now negative as well. right? Yeah. Okay. Now what does this do? Yeah, it's the same. How can that be? This is making me feel like if I do nothing, like if I multiply by a 0 normal vector, that it's not going to change the behavior at all. Whatever. Let's just roll forward with it and see what happens.
I feel like I should have glided properly just from that. Yeah. Let me verify that it's not the other thing that we need to do first, and I'm pretty sure it's not. Oh, okay, so it actually is. All right, never mind. I take it back. Okay, so now we're at the situation. He actually is gliding properly. I take it back. You can actually see him gliding properly there. The problem is we have to do the final thing that I said. If you remember when we talked about I thought he was going to complete stop. He actually isn't. He's only stopping if we continue to try and go to the wall. So we're at the point where we can finally fix the final problem that we had, which is what we were talking about before, where it doesn't continue the move after it does this. And so remember I said we have to do a loop where we try to correct the velocity during collision and keep trying to move him for the remainder of the time step, right? So that's what we want to do now. So basically what we need to do is say, okay, we now have to go ahead and do this sort of test where we're going over things. This part here, right? We have to do this for some number of iterations so that we can say we've got our, well, actually I don't mean to call it iteration.
Hold up. I'm just testing something out for myself now to see. I think I understand how he was doing that test now after kind of thinking about it for a sec. But honestly, it makes no difference. I feel like I'm seeing the exact same behavior regardless of which normal. Well, yeah. Min corner, max corner. If I back this up real quick and see, maybe there's just something different about the parameters he's passing in, and there has been all along. He always passes in rel, x, and y in the order of the corner he's changing, starting with the order of the corner he's changing, or not changing, testing. Player delta x and y are swapped as well. Yeah. Oh, wait a minute. I did have a bug. These are supposed to be x's. Yeah. So that definitely could have been contributing to some of the weirdness I was seeing all along. Okay, so now if I swap these back, does it make any sort of difference at all? Still seems like he glides just fine on the edge there. So maybe I'm missing something, and these wall normals just aren't doing what I think they're doing, but I thought they would have controlled whether you're able to glide or not. Because, I mean, one is pushing you, one wall normal vector ought to be pushing your velocity in the direction of the wall, and the other one ought to be pushing your velocity in the exact opposite. But I'll just stick with what his code says, because clearly I thought I was oh so smart and got this right, when either it doesn't matter or I'm wrong and I just don't understand why I'm wrong. As is often the case. And yeah, it just seems to me like if I'm testing against the max corner, the normal coming out of the max corner would be negative, right? Because we're at the top. Oh no, because y is going up. But that doesn't explain it for... Yeah. Okay. Well, I'm silly. Maybe. Yeah, no, because... Yeah, no, because if x is... If the min corner is on the... is to the left, then the normal coming out of that would be this way. I don't know. Maybe it actually should be in the direction of the wall. No, because it has to be the normal coming out of the wall. That's the whole point of what a normal vector is. I don't know. It's doing what it looks like it should be doing, so I'm just going to leave it at that.
What we need to do is say, okay, we now have to go ahead and do this sort of test where we're going over things. This part here, right? We have to do this for some number of iterations so that we can say we've got our, well, actually I don't need to call it iteration, index, it's just iteration. I think I said 4 would be how many we do because we want a bounded number. We don't want to just keep going until it's 0. So basically what we would start out with is we'd have a t remaining, essentially, right? That starts off at 1.0, which is to try and do the whole move, right? And what we want to do now is say, okay, we have this, that player delta, which is the value that we computed. That's how far we want to go, right? So we have that player delta, and the player delta, we're going to start off by saying we have all of the player delta to try and account for. We want to try and move him the entire player delta distance, right? And then when we do the code for hitting the wall, we say, okay, we start the t-min, meaning the minimum distance that we could go along it is, and I guess in this case we could say it's 1.0, right?
We get caught up and write this loop. So we're going to go for I in 0 to 4 for 4 iterations. And does all of this go... How did he wrap this? I feel like we only update the position after. So I think this ought to go like this. Whoops. Like that. And this should be until it equals 4. Or should it be inclusive or not? I think we want to go 0 to 3. So it should not be. Yes, that is right. And then t-min's down here, wall normal's here. And I guess we'll just keep on subtracting out of that t remaining until we can start to glide.
We start the t-min, meaning the minimum distance that we could go along it is, and I guess in this case we could say it's 1.0, right? Excuse me, is how far we want to go. And then when we finish, we know how much of the step we've actually used, right? We know, I'm trying to think of how to say this. We know once we take one of these steps, we know how far in t we've gone because at the end we have a new t-min, right? We've updated t-min to be the percentage of player delta that we've used. Does that make sense? So essentially our t remaining, right? We subtract away whatever the inverse of that t-min is, because essentially we've sort of said, and I guess we could do it. We could do the math. I'm trying to think if this is a good idea or not. We could actually do the math such that we actually are always just using t-min if we want to. Maybe I'll try to do it that way. So we start with our t-min at 1.0, which is we can move the full distance along the player delta, right? And then we go in here, we update t-min to be how far we actually have moved until we hit the wall. And then we try again to move, with the new t-min, and we keep reducing it. And if t-min ever falls to 0, so basically like, and t-min is greater than 0, if t-min ever falls to 0, we've done the entire move and we're done, right? So that's totally fine. So basically, what we want to do is say if we didn't hit anything, right? Because each time we update this, our t-min will go down to the distance that it went. Now, you know what? Just thinking about this, the sense of it's just wrong. I just don't think I can do that. Yeah, I can't. Sorry, in my head, I just can't figure out a way to make that work. We'll see after I write it with the 2 variables. We'll see if there's a way to do it entirely in t-min. I don't know if there's or not. So I'm just going to say that we have some time step remaining. We have the t-min, and we basically say how much of the t-min do we use, and then at the end we take.
Well, I can't really do that the way he's doing it, unless like I can have this be conditional in some strange sense, where t-min I guess t remaining is greater than 0. What is this complaining about? Cannot convert untyped value 4 to untyped bool from untyped I'm not even going to try and understand what that means. That seemed like a wrong thing to do, and so I don't even, just want to beg for forgiveness and say if t remaining is greater than 0, if not greater, I guess it would be if less than or equal to 0. Hopefully that's right. We would do a break here. And that would be the way to do that, I think.
In, and we basically say, how much of the team in did we use? And then at the end, we take t remaining and we subtract from it whatever was left of the team in, right? So basically, if we got to go the entire if team in was the entire way, so it was 1.0, right? We would subtract from it. Sorry, no. If team in was the 1.0, we'd subtract the entire thing. Yeah, so we always subtract how far in team in we actually went. Yeah, that's right. So, okay. So what we have to do here is say, all right, here's our player delta, right? And our t is how far along this we've gone, right? So when we do our team in, what our team in tells us is where we stopped along this line. It tells us a percentage, right? From 0 to 100%, right? So it ranges from 0 to 1, where we stopped. If we went all the way to 1, right? If we went all the way to 100%, we're done. So we always take whatever our team in comes out and we subtract from how much we had of t to begin with, right? So in this case, right, our team in is, when we first start out, our team in could be 1.0, and we could go the entire way, and we're going to stop when the t remaining gets to 0. But on subsequent times through the loop, we could just say we have only however much t we actually had left to use, right? And then we go from there. I believe that would work just fine. And then what we want to do is say, well, when we do our updating, right, we need to do the updating every time, right? Because every time we hit a wall, we need to update the player location to that point, right? And then we need to update, excuse me. And then we need to update the velocity to get rid of whatever part's part of the wall normal. But we have to do the same thing, right, for our player delta. So our player delta has to be chopped so that it's not trying to go into the wall anymore either. So basically the exact same equation where we do that bounce, we have to do that for the player delta as well, right? So we get rid of whatever portion of it's trying to go into the wall. Now remember, this offset is somewhat expensive. So really, we could decide just not to do that offset, the player positions thing, right? We could decide to do the player position thing outside here and have a thing called total player delta, which basically says what part of the player delta actually got used, and we'll sum it. So we'll say total player delta, right, is going to add whatever the step was that actually was used, right? And then what we need to do is we need to update that player.
Hold on. Hold on. Okay, so we're going to sum the total distance that the player has traveled over each of these iterations. I can totally appreciate the significance of that. Using this iteration's t-min, we get a modified player delta, so we get to this total. And why is t-min undeclared? I guess these are going up here in this loop here. This should actually go, okay. Okay. This is looking more right. So update the change in velocity every time. Okay. Because that's just that one value that we calculate on each iteration. But the position gets modified out here because we don't know where he's actually going to be until we get all this business. And this is actually going to be, yeah, we don't need that multiplication out. It's just, yeah, whatever the difference is, offset it from the old player position. So that means we just have to declare that right there.
Actually was used, right? And then what we need to do is we need to update that player position. So this thing where we do the rel old player. Oh, well, I guess, never mind. So I guess since that is something that we're actually still using inside the loop, we might as well keep it this way. Since we're still using the entity.
Oh, God. I had it, and then I didn't. So then he's just going to leave that out, actually. right?
The entity P. And so old player P, I believe old player P is never, I don't even actually know why we still have old player P. We're just talking about entity P really this entire time. And that's easier to update. So I'm going to go ahead and say that we do it this way. And I might get rid of old player P, since old player P is not actually used anywhere, as far as I know. Okay, so it's used there. So we just want to snap it once at the beginning, so that's fine. I'll leave it around.
Oh, this is not going to be right, but we'll just go with it. Where is that? I guess I just called it rel. Rel. Jeez. And he's basically just saying, don't use this crusty variable we declared earlier. Just work off the current position. Sure, why not?
All right, so I got to update the entity's position with this new position. I got to update the velocity with the new velocity, and then I got to update where we're trying to go to with the new amount that we're trying to go to as well. So let me take a look at that. We don't want total player delta. That's just regular player delta now. There we go. And so let's see how that does. There we go. So there's our skating. Oops, still getting a problem there. That doesn't look quite right. So we still got a bug, but we're almost there. Just not quite. Just not quite there. All right. So what's our problem here? We did our offset properly. Oops.
Whoops, changed the wrong loop. That was dumb. Here we go. Getting mad at me because I wasn't using that iteration counter. So I just expect that we're gonna have the same issue that he's having, and it's not quite working yet, but you can kind of see that even though I'm holding down into the wall, we like skid just a second before we come to a complete stop.
My laptop screen has gone to sleep. That's not going to be very good for reading the Q&A, certainly. Let's try that again. There we go. And, okay. So what we need to do now is figure out what I did wrong there. We're updating, what are we updating here? So let's make sure I've got everything correct. So we've got our absolute tile Z, we've got that. We've got the centered tile point is being computed properly. Yes, we get the tile value. This is the entity width and height. That's based on that. That's all correct. We're subtracting entity P, which is the thing that we are updating, so that's good. And then we do all of our testing, we get our wall numbers back. We update the entity P by whatever the player delta was that we computed. We remove the part of the player delta that would have gone against the wall normal, which I believe is what we wanted to do. And we update the velocity of the...
I wonder if this just goes back to the wall normals being right or wrong. That would be X. This would be Y. I wonder if the wall normals being correct now actually makes this do what it should do. Nope. Still not seeing any difference. So much for that.
Guy as well, based on that wall normal. And then we take away whatever the amount is that we stepped forward, which seems... I think... Okay, so I may be double counting that. Let me think about that. So I think I'm double counting that because if I were, although that shouldn't have really been in effect. The second velocity should have worked either way. But yeah, so you would still go the whole player delta because we are accounting for the fact that player delta is getting smaller. So I think actually technically this should always be 1.0. And then when we subtract it out, it's just we subtract whatever proportion of the player remaining we used, if that makes sense. I believe that's correct. Yeah. So I think that was our only bug. Not sure if you saw what happened there. So I'm not sure we're still entirely correct. I'm a little bit nervous. There's a weird thing that's happening there, which is, I believe, because our epsilon's too high. Like,
we'll see if this is actually gonna work for us. Nope. Okay, what did I do wrong? Let me make sure I didn't leave these wall normals in an incorrect way. Too easy to make those mistakes. Update the current velocity like so, off of the wall normal. Same thing with the position.
Portion of the player remaining we used, if that makes sense. I believe that's correct. Yeah. So I think that was our only bug. Not sure if you saw what happened there. So I'm not sure we're still entirely correct. I'm a little bit nervous. There's a weird thing that's happening there, which is, I believe, because our epsilon's too high.
Maybe I did not save this right. Come on. Nope, we are not grinding. Where's my grind? What did I even do here? Oh, yeah, he changes that.
The fact the player delta is getting smaller. So I think actually technically this should always be 1.0, and then when we subtract it out, it's just we subtract whatever proportion.
Yeah. Oh, man. That's disappointing. Even writing the code straight out. Or at least when you think you have, does not produce the right result. And that t remaining value is definitely starting out at 1. Well, might have to spend some time off stream figuring out what the hell happened here. Oh, I didn't update this. This should not be working off of the velocity. This should be working off the player delta. Yeah. Didn't catch that. Ugh. Okay. Now we ought to be good. I guess I shouldn't assume, but yep. We're good. So now as we grind into the wall, we kind of lose a bit of velocity because we're getting that sense of friction. So that's nice. But I guess I don't see what else he's worried about here. He's acting like he's seen a bug, but I don't see anything wrong. What gives?
Right. Yeah. So I'm not sure we're still entirely correct. I'm a little bit nervous. There's a weird thing that's happening there, which is, I believe, because our epsilon's too high. Like you can sort of see, I don't know if you can see it kind of when you go, he moves a little closer. You know what I could do? I could, we had a key, that's what it was. I could make it bigger. So you can kind of see he squishes into the wall a little bit, and I believe what's happening there is our epsilon actually stops him before he would actually get to where the wall is. And so as he moves in a slighter fashion, he can actually get a little closer to the wall. So I think what we want to do is we want to make our epsilon tighter than it was. So I'm going to say, so the epsilon, the problem is the epsilon is only in player delta space, which is not great. I don't think that's particularly good. And I feel like we should probably get rid of this epsilon eventually anyway. In the real collision detector, I think what we'll do is just not have it, but that's a separate issue. So let's take a look and see if that's a little bit better. Of course, that's too close. Yeah, you can see why you don't want to have these epsilons, right? So we want to do something that doesn't actually have to have the epsilon. This may be good enough just for now because, like I said, we want to do the regular collision detection. We want to do it a little differently anyway when we're actually going to do it. So it's probably better to deal with those things there, but there is that little weirdness that I don't love. It's kind of hard. You can see it, right? You can kind of see it. Yeah. We also have that problem of like the player's velocity as it gets clipped. It's causing his facing direction to be like changing very rapidly in the when he actually hits things. So we probably have to pick his facing direction on something a little more stable as well. But yeah, you can see can kind of see how he scoots into the wall a little bit. So that's just lame right there. And so I think now that I think about it, the fact that this epsilon is in the wrong space is really most of the problem there. So thinking about what would have to happen for that, essentially, so when we actually do that t-min, you'd have to actually say, you know, how big is the player delta, and you'd have to adjust based on that. So I'm not sure exactly what the best way to do that would be, because if the player delta is really small, then you would want to use a really small delta. So you want to actually make that minimum a little bit different. So what I could do is say that the epsilon's not going to happen here. You know, the epsilon's going to be happening outside, and that would be better, but still not fantastic, right? So
okay, no more epsilon. Why not? If you say so.
Essentially, you know, in the case where we actually did hit something, so I say hit equals false. In the case where we actually did hit something, I could apply that epsilon outside, which is, again, not particularly great. Having an epsilon at all is not good in general, but I could say if hit. And if in the case that we hit, we also know that we only need to do these when we hit. So, you know, we could do something like that, so that we break out immediately and don't have to do the test. I don't know if that's probably not really worth it. But we do know, for example, that we don't need to update any of these unless we actually hit. So okay.
Okay, so inside of these test wall conditionals, essentially, actually this should be true now. Set that in there. And then out here, I guess we're still in, okay, so basically bail out early. I can make sense of that. We still want to update the position we're trying to get to, or no? I see. 1 t-min times player delta at a time. We're updating the position. Okay, and then the second we hit, oh no. I was like, what is going on with my code? It's because I'm wrapping. I wanted to wrap, remember? That's not gonna work. Let's just split it up all on one line, I guess, or all on each line. Like that. Like so, and then if we didn't hit, we break, or is that the opposite?
So in that case, if we actually did the hit, then we would do, yeah, but I can't quite do it that way, I guess. So all right, never mind. Never mind. I thought we were going to be clever, but we weren't. So in the case where we hit, I'll just say this equals that epsilon there at the end, and
oh, okay. So we're not going to bail early. And that means I did this for no reason, so that's great.
The only reason I'm thinking that that's the case is because now I can actually see whatever our t remaining was. Our t remaining we could actually use to boost that epsilon up to larger values based on how far we thought we were moving. Because I believe that most of it is, well, I'm not actually sure. No, you know what? Why did I do that? That doesn't really make any sense. Because there really isn't that much information that I could use outside. It's still the same as the information that we have in here, right? I could just do whatever I was going to do, I could do in here. So I'm going to leave that way for now.
Fine. So be it. Can't remember how many zeros we're leaving in there. Just 4? That's fine.
I could just do whatever I was going to do, I could do in here. So I'm going to leave that way for now. Because I don't see a super easy way to fix that without doing something better. Because again, that epsilon is just going to be, the problem is when you actually do hit the wall, you've got that epsilon that wants to be a little bit different. Yeah. See, that's just bad behavior right there. You can kind of see, I don't know if
I did something bad. Whatever I did just now to back that change off, Maybe I just didn't save it properly. Because I'm not gliding anymore. Oh, now I am. What? No, what? That's super weird. Why am I getting stuck? This wasn't happening before. Was it just because the epsilon was too small? That kind of looks like that was the case. Okay, so 4 zeros, 4 leading zeros, not good.
You can see that well on the stream. I believe Alt-1, or I believe there was some way we had that was supposed to zoom in while zoom in is running. Control-1, maybe? There we go. Ooh, I guess that doesn't work, unfortunately. Can I zoom in there? So unfortunately, while I'm zoomed in, I can't animate. So I guess so that zoom effect doesn't really work for this. But you can kind of see what's happening as I go in there. And I don't know, that might just be another bug we could look at in a little more detail. But basically, I want him to stop directly on the wall and not have that little stuttering behavior. And I guess I'm not entirely certain that that's the epsilon. So I guess what I could do too, you know what? I'm going to go into the Q&A a little bit just because I feel like I can. I want to just look and see if there's another bug in there. I just want to watch what the behavior is that happens when he hits that wall. So I can do that actually pretty easily because I know that he's going to hit this wall, right? That's the wall he's hitting. So if I want to, I can stop just when he's about to hit that wall, right? Which is right here. So let's take a look at what actually happens when he hits that wall. None of these other walls should hit, presumably, because he's just hitting that one wall. Yep. And so let's see. What's our team in? Our team in is 0.75.
I guess I really want to understand why the wall normal off of the max in the X direction, because I'm thinking of the max corner in the X direction has to be, you know, to the right, and therefore the normal of this wall on X would be out this way, so X would be negative. That's what that unit vector would be.
And what's our player delta? Our player delta is negative 0.2, so he's trying to move that much, and he's basically not moving in Y at all, right? It's an E negative 0.6, so that's a very tiny value in Y. All right, so when I update my entity P, I'm going to move him by the amount that he was able to move, right? Which is 75% roughly of the way to the wall. And so we go ahead and do that. Now, where does that leave him? The player position, let's see, entity P. Where does that leave him? Oops. Versus where the wall is. I'm going to delete some of this stuff so I can start fresh. Where does that leave him? So we have tile map, tile side in meters, right? That is, oops, divided by 2. That is about 0.7. And so we're going to do our offset of the player now. So we do that offset, and we get an x of negative 0.19, which is actually nowhere close to this, which is fine, because we also have the player width to account for. So what's the entity width? The entity width is 1, so that's 0.5. So that's stopping him right on. That's doing exactly right, is basically what's happening. So I think we just have another bug here. Okay, so entity dp, we're updating the velocity of the fellow himself. We have clipped his x velocity away, which is exactly what we want. We are taking the player delta, which is this right here, which is how he's trying to move. That is clipped as well. And we are taking the t remaining, which was all of it, and we're reducing it to just what was left after the move, right? And so I think that's what we were expecting. So that's fine. Let's see what happens now. So now we got a team in of 1.0 again, and we're going to see whether or not we collide with anything. Now, my understanding is we should not collide with anything, right? Because we are free and clear at the moment. So I feel like if I were to set these, we should not hit one of them. And we don't. So that's good. That's behaving as we would expect it to. So now we have to do our offset again. We have the player delta. The player delta has no x component whatsoever. And the dp, let's see here, entity dp also has none. So they should really not change much at all except in y, right? And that's fine. So there we go. And player delta does not get updated. Tmin was 1.0, so now t remaining is 0, and we should fall out of the loop. Yeah. So we did exactly what we thought we should do. So now the question, I guess, is just the second time through, I guess it was wrong. Must be, because that is apparently correct. that all looked exactly right to me. Nothing bad happened there, right? So what is happening with that nonsense? So in order to fix that, again, I'm going to lean on our loop live code editing, as I so often do. I'm going to set that up and then do this, right? So now he's just constantly careening into the wall, and that'll make sure that I can basically debug the exact case that's happening, right? So what I'm going to do is I'm going to set that breakpoint again. I'm going to set that breakpoint here. When he hits the wall, I pretty much believe that that loop operated as it was intended, right? So it comes out here, and does its update. Off we go, right? It does its little dance for the facing direction, which is fine.
Okay, I think I get it now. Why these wall normals are the way they are. It's because if we're hitting the min corner X, we're actually hitting the left side of the wall. And if we're hitting the max corner, then we're hitting the right side, which means we'd go positive X, and yeah, okay. I don't know why it doesn't seem to make any difference in the actual behavior that I'm seeing. Like, I've swapped these back and forth several times now, and the outcome, like, it's the same bug. We're still able to glide. So this seems like it should be producing a bug. Shame on me for thinking I knew better than Casey, I guess. But, I mean, you see that. I feel like I shouldn't be able to glide nicely like this if I have my normals swapped. That just makes no sense to me. But if we run straight in, we still have the same behavior where we just kind of jitter back and forth until our facing direction points up or down based on where we were going last in that direction, I guess. Yeah. So I don't know, but I think I at least understand this. I had my intuition. My intuition was bad after I thought about it. Well, my intuition was trying to lead me down the right path, but it was flawed. Yeah, the more I look at this now, the more this makes sense.
And yeah, and I think that should be it until the next call to move player. So let's see what happens in that call. So in the next call to move player, we come in here, and our DDP should again be trying to accelerate him into the wall because I was pressing straight into the wall. -1, exactly what we would expect. We go through and we compute our stuff, as it were. Min tile X is 1, min tile Y, max tile X is 1, max tile Y. Believe that's correct. Oh, is that correct? Yeah, okay, because we're about to expand it by the width of the guy. Yeah, so we're checking everything. Yep, so that's fine. So now the question is, we should immediately, again, hit this wall, right? That's what should happen, if I'm not mistaken. Oh, and we do not hit the wall. We don't hit the wall at all. Why do we not hit the wall? Is it because our velocity was not big enough yet to hit the wall? That could be, certainly. That might be it. We may have stopped just short of where the wall is, but I feel like we were right on it. So if that's the player delta, why didn't that hit the wall? Where is the wall X would be the real question. Unfortunately, it's kind of hard to figure out what that value actually is. So all right, so let's go ahead and say, what is the abs tile X and abs tile Y of that guy? So let's do this again. Run. Go ahead and run. There you are, my friend. So I'm going to go ahead and stop it in there, and I want to see what the actual position of this wall is. Oops, I should make sure that we're actually looking. Okay. So what is the wall coordinate here? What actually is the max corner X that we're stopping at? It's 1.25, right? 1.2005. So let's find out where we actually move ourselves to when we decide that we hit that wall. Where are we? So we're at 1.25 relative to the tile. We are -2 away. And what's that tile side in meters, right? Tile side meters is 1.4. So that basically, oh, and I guess yeah. So it's a little bit confusing just because since we do everything relative in tile space, the 1.2 is how far away from the tile you would have to be. And I'm not sure exactly where this guy is relative to that right now because that's kind of a hard computation to do in one's head. But, so if the max corner X is 1.2, then that means if between two tiles, right? If between two tiles is 1.4, then basically he should be 0.2 away from his current tile, which is exactly what he is. So he should have hit the wall the next time around. And the fact that he didn't hit the wall is somewhat troubling, I believe. So yeah, I think we're back to my original thesis, which is we've got a bug, or something that we don't, a subtlety that we don't understand. This is not a problem with the epsilon. Really, this is a problem with the code. So if I come in here, and I'm going to test this wall again, what I want to do is I want to take a look at what happens when we're supposed to hit that wall. So what I'd like to do is say, okay, let's figure out which abs tile X and abs tile Y we're on when we do hit this one, right? Let's figure out which one that is. So abs tile Y is 5, abs tile X is 0. So abs tile Y is 5, abs tile X is 0, right? That's what we're looking at for the one where he actually does hit that wall. And so what I will do now is I will let him hit the wall in that way that he likes to do. And then I will go to the next time round, and I'm going to step into the case where he is supposed to be interacting with that wall. Abs tile X, abs tile Y. So I want abs tile Y to be 5, so we're not quite there yet. We got to go through these two X's first, right? X is 2. Let's finish that up. Let's see. Oh, no, I missed it. The so slow iterating watch window is so frustrating. Ah. All right, let's do it again. Thank you, Visual Studio. Like, apparently it's an unsolved problem in computer graphics to update the watch window when I hit step. It's just so ridiculous how bad it is.
Watching him deal with this reminds me of this demo I saw from the guys who did, I can't remember what the studio is or even the game, but they basically did a demo of their entire development workflow, and they had like a compiler, not a compiler, debugger that could travel forwards and backwards through time. Like, it recorded the state of the debugger even going forwards and backwards. So it was actually, they could like rewind through that part that he just got stuck on and had to redo over. And I want to get on that level, because that would be, you would feel unstoppable if that was the development workflow that you had. Those guys are the real deal.
All right. So we've hit it once, and now we're going to go again, right? And now I'm going to go ahead and run in here. So that's 0, 4, 1, 4, 2, 4, 0, 5. So this is the one we want to know about. We come in here, and let's see. So we've got our relative player location. Let's see what that is. Our relative player location in our min corner, our max corner. Let's take a look at what all our values are here. So his relative position is apparently higher than what I thought it was. He's got a little ways to go, but it looked to me when we actually did the computation before, it looked to me like he didn't. So what is going on here? What's the issue, if you will? What's our test tile P? What's our test tile P? It's 0, 5, 0, and 0, 0, which is what we would expect. And what's our player, our entity P? Entity P. What's that at? Our offset. So that's a different offset than I thought we ended with before, right? Am I imagining things? I thought we ended with a totally different. I thought we ended with a totally different entity P than that last time. All right, let's step through it one more time. So there he's going into the wall. Which one am I going to stop at? I'm going to stop him here. So there I've hit the wall, right? And now I'm going to do my update. Step to here, update. What's my entity P? That was the entity P we were supposed to get. So what happened to our entity P? Why did our entity P, did it get changed in the second time through the loop? Because it shouldn't touch the X, right? So what happened here? It did touch the X. It did. What? Ah! Oh, the bugginess. Oh, did you see it? Oh, it's so awful. I forgot. I said I was going to get rid of old player P, and I didn't. Oh, the pain and suffering. You saw it, didn't you? Oh, man.
You know, I watched him look at that and go, why do we need this? We're not even using this. And then he said, it's okay. I'll leave it alone. And then I didn't think anything of it, but that makes perfect sense because we're iterating on the position with each iteration, and we're just updating it, you know, according to well, where does the T remaining? Where else does that even get used? Oh, I guess, okay. Yeah. So that just says, well, we bail out early with T remaining if T-min takes it all the way down to 0. Okay. And at that point, the player's position is exactly as close as it's ever going to get to the wall before it starts grinding against it. And so now I suspect, yep. So that bug that he was trying to solve, it's so weird because I didn't even understand why he was upset looking at that variable. And then, again, he saw that it was being used here. And then he just immediately forgot to get rid of it. Yeah. Okay. That makes sense.
Boy, I'm glad I stepped through that. That was a good one not to leave in there. Hey, look, it's perfect now. Oh, that was terrible. That was terrible. It's coming out. The owl is coming out, people. That was a bad typo. And I almost left it in, too. I was like, it's not the final collision detector. Well, it's not the final collision detector. It's true. But you shouldn't leave that garbage in there. That's just awful. Oh, that was bad. All right. Looks like we're fine now. No more cause for alarm. I wasn't happy with what was going on in there at all. That was just bad news. So the other thing that I was thinking about is I don't know if we want the acceleration to determine which way the guy is facing, because it's a little weird right now, the way that it's working with velocity, but I don't know. All right, so I'm glad we pushed through that. We can go ahead and actually go to the Q&A now. Wow, okay. So yeah, that took an extra 20 minutes of debugging time to find one typo. Oh man, but that's what you get for putting in typos in your code. So okay, we're pretty clean now. I don't think we've got any more problems with that. And hey, it's a lot easier to skate through now. Even with a rectangular collision, it's way easier to skate through those doorways, which again is why sliding is so important. You don't think about it that much when you're playing games, but being able to slide smoothly along walls is like really important, right? It's what makes it fun and easy to play a game and not feel super janky. So it's super important to get that slide in there. So it's worth the effort, trust me. So anyway, and it'll be even better when we have a circular dude, because then the normal that you're pushing off on will sort of help you slide into doorways easier, better as well. All right, so I think we're all good. Let's go ahead and go to the Q&A. Please prefix your questions with Q:.
And as usual, as much as I'd love to have time to sit in and listen to Casey's Q&A session here, I have to get going. Pretty solid day, though. Just over 2 hours on stream. I kind of expected to hit more snags, and of course I did have... what was that? I mean, basically the same kind of problem. He didn't update that old player P. It's the same. It was like the same thing, and I didn't change the, the update of this. I did not update this equation to change it so that it was operating off of the player delta vector instead of the velocity. And yeah, so definitely feeling good about being able to kind of be in lockstep with him here as we go through each day. And the past 25 days have just kind of flown by. When I started streaming, didn't have any of this on the screen, right? Just had, what was it, like the... I guess I'd have to go back to the first stream to see what it even looks like. But we didn't have bitmap loading. We didn't have any notion of a tile map. And now we can just, wander through these rooms with the Handmade Hero and just be stuck on the same level forever and ever. So who knows, another 25, another 50 days, it'll fly by. And before I know it, I'll be banging my head against writing a Vulkan renderer for 100 days. So that'll be great. So thanks for hanging out with me. It's been another fun week of programming Odinmade Hero. I'll start off day 51 on Monday next week, where we'll do some more stuff with entities, moving on from the collision detection stuff now that it's in good working order for us to move forward.